Hello Internet, welcome to 6th video of MERN full stack tutorial series. In last video we reviewed and implemented schema merge, mutation queries, also reviewed the need for input type in mutation queries. We further enhanced the schema for book club. We also installed nodemon package and wrote starter script. Finally, we learned few GitHub commands for version control. In this video, we will implement database, that is MongoDB. Before though, let's take care of local Git branch. On VS Code, we are on master branch. Let's run git branch, branch, the branch name. We are on video 6th, so let's create a branch and let's check out the branch. So we are now on video 6 branch. Now let's talk about MongoDB database. For that, let's open up our browser and go to mongodb.com, and let's see in the official website what they talk about MongoDB. So here the MongoDB is a document database, which means it stores data in JSON like document. So here as we can see, this is a JSON like object. So this is how the data is stored. So if you want to compare and contrast this with relational database, the entire object corresponds to a row in relational database, and each field corresponds to a column in relational database. The one advantage or one enhancement here is each column can be an object in itself. For example, this address is an object by itself. This is not possible in SQL or relational database. You need to have multiple tables and those needs to be joined. And in MongoDB, this nesting can go much deeper. It need not be just one level. The street, for example, can be a nested, and that values can be nested objects. So a record or a document in MongoDB can hold very rich data. The second point about the MongoDB is its powerful query language. So the MongoDB really has very powerful operators where the document can be transformed, it can be aggregated, it can be processed, and all this processing can be done on the database level itself. We will see some of these query features in our book club project. So another important thing about MongoDB or any document-based database is that schema is not enforced, meaning multiple documents in a collection need not have same columns. In fact, they can have completely different key value pairs. So that schema is not enforced by MongoDB by default. A schema is not enforced. This bodes well for any future enhancements where the data need to have different columns or it can have additional columns. So you don't need to um, refactor the earlier code or refactor the earlier data. However, it also gives options where a schema validation can be done if that is a need of a project. And finally, uh, we can have the relationships also implemented in document based database. That means in real life, the relation between two entities can be modeled in database with two types. One is reference and another one is embedding the documents. So we will see this in practice in our book club project. Finally, MongoDB is open source. We can install we can install the MongoDB database on our machine or on our servers. We can manage it on our own and we can use it in our project. There is also a cloud offering which MongoDB provides, which we will be using in our project. And it has a free tier version. That's what we are going to use in Book Club. Let's start with MongoDB Cloud offering. It's also called as Atlas. So for that, on mongodb.com, let's go to Start Free. And we can either sign up with Google or we can use our own email ID and password. I will choose the Google option. Okay, so the first thing is we need to create an organization. So let's create an organization. We will start with MongoDB Atlas. We will say, I'll give the organization name, click next, and create the organization. After that, we need to create projects. So project name is Book Club. Here we can add other members and we can give permissions, read write or other collaborators. Here we will just skip it. We will use our own single email ID and say create project. Next step is to create clusters or build clusters. So here we have three options with the different rates. For us, we will be using the free version. This is useful for trying out prototype and for our learning the MongoDB also. So I'll leave all the default values here as it is. I'll just name the cluster. I'll change the cluster name to Book Club cluster and create cluster. Okay, it will take about 1 to 3 minutes to provision a cluster. Meanwhile, we can set up a couple of security features. One is the database network access. So we need to add IP address from where this MongoDB database can be accessed. So let's add IP address. So there are a couple of options by default. Add current IP address, meaning the machine from which we're working, only that machine and will be able to use or access the MongoDB. So I will use this allow access from anywhere, which is not recommended for production deployment. This is for our test. So our project or prototyping, that's why we are using this access from anywhere. So let's confirm. Second is the database access. So the database access is we need to create users and who will have access to uh, this project and this cluster. So there are a couple of options of authentication. We'll go with the password method. I will say the username is book club db admin and I will use this auto generate and secure password. I'll copy it and save it on my notepad, or we can choose our own password. And here there are different options of Atlas admin, read write to any database and read only options and other advanced features. So we will leave it with read and write to any database and click add user. The user is added. Like that we can add other users and we can edit or delete users as the project requirement comes along. Now let's see the cluster. The cluster is created now. So let's go to the connect option. and it gives different options from where we want to connect to. Do you want to connect to MongoDB with shell or connect with application? So this is what we are going to connect with. There are different drivers and different versions. So we are, since using Node.js, this is what we are going to use. Let's copy this. This is the connection string. We are going to need this when we are connecting it from our project. The setup in MongoDB Atlas is complete. Now switching to VS Code, we need to install a package called Mongoose. So we are on the backend project at root level. Let's use npm install Mongoose, save flag. There is a Node.js driver for MongoDB. We can very well install it and start writing the code with MongoDB driver. However, this Mongoose package provides a straightforward schema-based solution to model the application data. It includes built-in typecasting, validation, query building, business logic hooks, and more out of the box as per this official document. So we can model the data within our code, and it makes interaction with MongoDB at higher level. Let's make a section for Mongoose in our VS Code index.js. The first thing is to require the package Mongoose we installed, and call it Mongoose. And there is a simple method to connect to MongoDB with this Mongoose. So here we need to pass what's called as MongoDB URI, and there are a couple of flags which we need to set to true. This is as per the document on Mongoose. Otherwise, they will give some errors on running the scripts or queries on MongoDB. And it takes a callback function. So let's say if there is an error, then we will say error. Else, we'll say connected to MongoDB. Now let's copy the URI we got when we set up our account and set up the cluster on Atlas. So let's copy that text here. Now, so here we need to replace this password here with our actual password. Now, combining the passwords in clear text along with the code is really bad practice, and it is a security vulnerability. So the ideal way is to separate out the passwords and other environment variables from the code, and give access to those passwords and environment variables to only the admins or only the systems who need really the access to it. So basically we need to parameterize such values, and those should not be visible within the code. So there is an package, it's called .env. So let's install that. So it's npm install .env and save. So while that is install getting installed, let's go to the backend folder level, and we need to create a file called .env, and here we can have that um, key value pairs. For example, we need to segregate the password, and just for demonstration I will say the password is password secret password, and let's save it here. And going back to the index.js, we see the .env is installed, and the way to access the variables defined in .env is as below. First, we need to require the .env, and we need to call the config function on it. So once this is done, all the variables defined in .env will be available under process.env dot the key value pair. So here we defined a password. So let's just log it out, save it, and because this is not a valid URI yet, let's just comment it out for now. Save and run our starter script, npm run start server. Okay, see here the secret password is logged, which we defined here. So what I will do is, here I will call define a MongoDB URI and copy the entire URI section and paste it. And here I will replace this password with the actual password we defined, and in the connection function we will simply call process.env.mongoURI. MongoDB URI. So I updated the .env file with MongoDB URI, where actual password is also appended. So what we need to do now is take out this .env, this require function, to all the way to the top, so that the process.env is available for the entire file. After that, we don't need this console log anymore, and we are calling this MongoDB URI via process.env.mongodb URI. Also, this 4000 port, what we were running here, is hard coded. This is okay for the development environment, but when we deploy it to production, um, the deployment server will have a different port enabled for it, and it might be dynamic. So we don't want to hard code a port here. So I have defined the process, the port within this environment file called port, and we can access here process.env.port. And when we deploy it to in production, the environment variable with this port will be defined dynamically. Also, let's save these changes first. And also, if you remember some time back, we had created this Git Ignore file where we said we don't want to upload the dependencies such as the node module files. Similarly, we don't want the .env file to be uploaded to GitHub. Otherwise, the whole purpose of segregating the code with these secrets and environment variables will be defeated. So we need to say ignore the .env file when the git commit happens. Now let's go back to backend and let's run npm start run start server. Okay, so the express server is running at 4000 port. So again, the same 4000 port has been defined in .env. Again, in production, it will be dynamically defined so that this code will also be production ready now. Also, we are seeing connected to MongoDB here. So there is no error connected to MongoDB on Atlas. So everything is set up now. Now we are ready to start modeling our data and start writing to MongoDB. For modularity, let us start creating the folder at root level for MongoDB, similar to the GraphQL. And then within the MongoDB, let's create a file called models.js. So here let's require Mongoose, call it Mongoose. So Mongoose is schema based solution. So we need to create schemas. So in the database MongoDB, we will have three collections, one for user, one for book, and one for authors. Let's start by creating collection for users. So first, let's call new schema, new mongoose.schema. It takes an object, and this is where we need to define the fields. Okay, so the instantiated values, we are creating user model, a user collection. So let's start off with very simple model. We'll keep enhancing it as and when we implement different resolvers and different fields. So before that, let's take a look or recollect what we had defined in our uh, user dev. So I'm opening user dev, user type dev. So on the right hand side, we have user type dev defined in the GraphQL. So ultimately, we need to support all these user fields: ID, email, password, name, avatar, books owned, and books borrowed. Let's start off with email and password, as those are the mandatory fields a user need to provide while registering. That is the entry point to our book club project. So let's define a field called email, and it is of type string. Also, let's create a field called password, and it is of type string as well. As I said, we will enhance it to define all other fields also. But for now, let's just define these two fields in the user model. In this video, we want to see that we can write data to MongoDB via GraphQL. So the next step is, once the schema is defined, we need to pass it to another function, that is mongoose.model. And here the output is user model. We're calling it as user model. Or we'll call it user collection. user collection, and we will pass this schema we just created, and the return model will call it as user collection. Now let's export this. Module.exports is equal to user collection. So this user collection, we can run different functions such as user collection.save, user collection.find to interact with MongoDB data. Similar to user collection, we will create two more collections, one for book and one for author. Now, if you recollect few videos back, we had created these resolvers for queries, and we will create the resolver for mutation also. Here we were referring to this mock data. So obviously now we don't need to deal with this mock data. Here we need to have access to this user collection, book collection, and author collection, so that when the resolvers are resolved, they interact with the MongoDB. So the way to do that is we have exported this user collection here from models. Now let's go to the index.js. Here at the top, we need to extract user collection is equal to require MongoDB and models. So in index, we got access to this user collection. So how do we pass this user collection to resolvers? So the way to do that is in server, when we define this Apollo server, we defined typedef and we defined resolvers. It takes third parameter or third variable called context. So in the context, we will pass this user collection. So once the user collection is defined, going to this resolver functions. So in resolver functions, now we'll have access to this user collection. So again, if you recall, in this book resolver, we had used two positional argument. One is parent and one is the argument. Now this context will be the third positional argument, this user collection. And that's where we will use this user collection and interact with MongoDB. Now we passed user collection in context to the Apollo server. Let's attempt to resolve this mutation, the register mutation for user. So this is the resolver index file, and we had defined the mock data, and these are the resolvers. So this was the root query, root type query. So now we need to resolve for mutation at root level. So for that, we need to have mutation defined at root level. This is an object, and the name of the mutation is register. So let's go to register. This is, again, let's implement an arrow function. So this will have access to four positional parameters. One is parent, which we are not going to use here. Second is arguments, and third is context. So for now, let's just console log what are these arguments and context. Args and context. So let's just make some space here by hiding the files, and the server is the Express server is up and it is connected to MongoDB. Now let's open the GraphQL. Let's refresh it, and we need to fire this register query or register mutation to be specific on GraphQL, and let's see what we will get in arguments and in context. So so on the playground, this is a type of mutation, and what we need, which mutation we want to run. The mutation we want to run is register. So it is giving in the information that mutation register, we defined that it needs to have an input type registration input. So we need to pass in this registration input parameters. So the way to pass it is we can define input type, input variable of type registration input, which is not nullable, and that will be the input to this mutation. Now, how do we pass this registration input? This is where these query variables will come into picture. Notice we also have HTTP headers. We will be using this also, but for now we will be using these query variables. So the query variable is an object. We need to define input type, and input type is an object. So let's see what we need to define. Here it is email, password, and confirm password. So let's just copy these values. So we will need to put it in double quotes, password, confirm password, and now let's provide the actual value. So let's say this is p@test.com and password, and let's say password, and it needs to be comma separated. So again, just to recap, what we did was we created the user collection. User collection is a MongoDB schema, Mongoose schema. So Mongoose schema we passed in to the index, and in index we passed it in the context to Apollo server. Now in Apollo server, these mutations will have access to that context as a third positional argument. Now to check what are these arguments and context, we are using the playground, and we are firing this query or firing this mutation register and see what values we will get here. Okay, so forget about the output for now. What we are interested is the console log. So this is what was there earlier connected to MongoDB. Now this is the first output, that is the arguments. This has input, email, password, and confirm password. This is what we precisely passed here. Also notice in the context we have access to user collection. So we can use this user collection to save or interact with MongoDB. So let's try to do that. So on arguments, let's use the deconstructor and use input. We will extract the input object, and here in place of context, let's extract the user collection. Now we need to instantiate this user collection. New user collection, and we need to pass in email and password. So email is going to be input.email, and password is going to be input dot password. Let's call this new user, and we can say new user dot save to create this user in MongoDB. So this new user dot save operation, and in fact any read write operation on the database is a async function. So we can use await. So if we want to use await, then this whole function need to be async. And then let's return true. So because we are using async function and we are dealing with database connection, there is always chance of some kind of error. So we need to deal with errors. So here we will use try catch block. So we will try this operation where we are trying to save a new user. If it doesn't happen, if there is an error, we will throw that error and it will be handled on UI. Okay, let's save it. Okay, no error so far. Express is running, connected to MongoDB. Now let's go to this playground and let's run the same query. So before that, I have the the Atlas open also. So the cluster which we created in the beginning of the tutorial. So the database or the collection, there is no data here. It's an empty collection. So now let's try. Okay, so we got an error. Less root cause or troubleshoot. Okay, I root cause the issue. The issue was in .env file where we defined this MongoDB URI. This W is equal to majority and there was a comma here. So that was causing an issue. So I have removed the comma after W is equal to majority. Now let's switch back and go to playground. It's the same query we have and the Express server is running connected to MongoDB. So now let's run this query again. So before that, again let's see the book club cluster is empty, and now okay, so we got the true, there are no error here. Now the moment of truth. Let's go to MongoDB and let's refresh. And voila, you see the book club database is created, the user collection is created, and we have the email ID and password what we passed in the playground mutation. So we are successfully returned to MongoDB. So in this video, we started off with setting up our user account and collection clusters in Atlas MongoDB. So we also discussed what is MongoDB database and what are its uh, advantages when compared with SQL database. Then we installed the Mongoose. We talked about why Mongoose is used in our project versus the native Node.js driver. We installed uh, the .env. We understood the need for it. We wrote schema, a very simple schema for user, and we fired the query, we fired the mutation on playground, and we successfully wrote it to MongoDB database. So from next video, we will start by implementing authentication. That's it for this video. See you in next video.